This is just a short video to show you how to use the GDB debugger to help you find seg faults that we're going to get from time to time. Just part of programming for sure. Okay, so the seg fault that I've created here, most of the seg faults that we're getting are from when you're doing arrays out of bounds for some reason. And those don't always create faults. So I couldn't force one this morning. So I've used a null pointer, which we'll talk about later. It's basically there's no memory associated with it. So in this line here, when I'm trying to access something from that array, then it's going to give me an error. Okay, so that's kind of what's happening here. Okay, so one of the problems with our um, segmentation faults in particular is that they don't cause errors as far as the compiling goes. Okay, so they're not a syntax error. Okay, they're a runtime error. So when I go ahead and compile this, it's just fine. Okay, it's only when I run it, I get a segmentation fault. Okay, and the segmentation fault doesn't tell us anything at all about anything. Okay. So a segmentation fault just means that your program is accessing memory that it doesn't have uh, the proper authority to do. Okay. So it's out of it's a memory access that's out of bounds. Okay. And the core dump, there's a file that it creates that, in some situations you'll want it to look at, but we're not going to mess with that. Okay. So when you've done this, when you have this issue, okay, the first thing that you have to do is recompile your program and give it the -G flag, which allows it to save debugging information. Okay. So I'm gonna do this again. In fact, I'll do it the correct way this time. So I'll do a -G, then I'll do the -OO with the segfault.exe, and then finally the segfault.cpp. Okay. And that doesn't do anything different. Okay. It's just, in fact, you can run the program again and it does the same thing. But this -G has saved information um, that the debugger is going to use. Okay. And then to run the debugger, okay, the next thing to do here is we're going to type in GDB for the GNU debugger. GNU is the company that creates a lot of, or the organization that creates a lot of the Linux commands. Emacs comes from uh, GNU, GNU, along with many others. Okay. And then you give the name of your executable file. Okay. When you do that, just pops it up here, gives us the versions, all that. There's a help file if you want. You can certainly do that. But from the GDB prompt, the main thing we want to do is run the program. Okay. If you run the program, that's all we have to do. It's going to tell us here exactly which line is causing the fault. Of course, the segmentation fault here is from the comments in the code. It's not from anything else. Okay. So here is where the things happen. Okay. So there's a backtrace command that you can run. Okay. That will sometimes tell us, okay, the same thing. It's not really telling us much. It's just telling us it's at line 6. Okay. So that's really all we're going to use it for. There are certainly other things that we can do in our program. Okay. And I think if type in quit actually to get out of there. Okay. So GDB is a lot more powerful than that. We can do things like set a breakpoint, which will be at a certain section of code hits. It'll stop and let you look at things. You can look at variables. You can step through a function line by line, all kinds of things. Okay, but um, but we're not going to do that for now. So the seg fault is the main thing we're looking for. Okay. So if you find yourself with a seg fault, watch this video and this will outline. I've done this in class before, but this just kind of puts it all in one place.